Okay, good morning. Thank everybody for coming today. My name is Phil McAllister. I'm the Director of Commercial Spaceflight here at NASA headquarters. And it's my pleasure to introduce the forum today. Having seen COTS be born and grow and evolve and be successful over the years, it really is a pleasure to be able to introduce the people on the panel today and hear their remarks. You know, when I first heard about this knowledge sharing forum, I thought it was a really great idea. The experiences that you're going to hear about today are unique for NASA. If you think about it, NASA has lots of policies, lots of good procedures, and lots of personnel that can help the management of a traditional NASA program be successful. But when we started COTS, there was no template for how to do this. There were no policies, no procedures. The people on the panel today had to create them. And that's what makes this forum unique, I think, today. And the good thing is that now we do have a template. These policies and procedures that help make COTS successful are available for future generations of NASA management and NASA program managers. And the good news is we are already learning some of those lessons. When we started the Commercial Crew Program, we had a template, fortunately, and we leveraged heavily the experience of the COTS program in developing and defining that program. It's not an exact replica because there are obviously nuances to every program that have to be addressed, but we did have an excellent and successful program from which to leverage. And most of the key features that you're going to hear about today have been adopted by the Commercial Crew Program and hopefully will be adopted by future programs after that. Features like Space Act agreements, having skin in the game, competition among the industry partners, emphasizing insight instead of oversight, and then most critical of all, having the companies make the design decisions, having them own and operate the hardware. These are just a few. I don't want to steal the thunder of the panel, but that's just a teaser of what you'll hear about today. You shouldn't hear them from me, obviously. You should hear about them from the people that actually created them. That are these 5 people up here on the panel. From left to right, you have Frank Culbertson from Orbital, Bruce Manners, the NASA rep to Orbital, Alan Lindemoyer, the COTS program manager, Mike Horkachuk, the NASA program executive to SpaceX, and Gwen Shotwell from SpaceX. So with that, I will turn it over to the panel.
Okay. Thank you, Phil. It's certainly a great pleasure to be here today and be here with my great friends from SpaceX and Orbital. We've gotten to know each other fairly well over the years, spent a lot of time together, and certainly created a lot of great memories together. So it's a real pleasure to be here to talk about COTS, and I think we should start by bringing us back to 2004, because COTS was really born out of the vision for space exploration that President Bush gave us. The vision called for NASA to build great new vehicles to explore deeper in space than we ever done before with human exploration, building a brand new rocket and a new spacecraft to carry our astronauts beyond low Earth orbit, and to replace the space shuttle. Because in order to afford to do all those great things, the space shuttle needed to complete its mission by completing the assembly of the space station and then be retired and then eventually replaced by our new spacecraft. So that caused quite a dilemma for the space station, because in its inception, the space station was to rely on the space shuttle for resupplying with cargo, the crew rotations, and to conduct the research on the National Lab for its entire service life. And when we made the partnership agreements with our international partners, there were commitments made by NASA that said we would take on a certain percentage role of resupplying the station over its service life. So the vision, although it's a great new opportunity for NASA, did pose a dilemma that by retiring the space shuttle, we had a shortfall in the ability to bring up the U.S. cargo and meet our obligations. And it also created a gap between the time the space shuttle would be retired and then our new vehicles would come online. So that posed a very interesting challenge for the agency. And when Mike Griffin came on board as administrator in 2000, he looked at that challenge as an opportunity. This is, to him, was an excellent opportunity to offer up access to low Earth orbit to private industry. Now, there had been previous attempts, and most of you in this room probably have lived through several of those attempts of commercial space. Early in the early 2000s, there was a program called the Assured Access to Space, Alternate Access to Space, and that was an initial attempt to get companies on board to provide these transportation services to the space station, but it just didn't work out. So Mike Griffin was very aware that private companies have proposed to NASA several times that they had the ability to do this. So Mike decided, let's give it a chance. If these companies can demonstrate that they have the ability to build new space transportation systems, then he knew that NASA would be a very interested customer for that service. So we all know the barriers to entry in space are very high, and that's contributed to those are some of the reasons why we didn't see these capabilities emerge in previous attempts. The barriers are just simply too high, and it takes a lot of capital, financial capital, human capital, and physical test resources and facilities to be able to develop something like this. So Mike said, let's put a very serious financial investment in place to help remove probably the toughest barrier, is to have enough financial capital to get started. And he offered $500 million. That was his, he called it, that was his bet on these companies. And that number is very interesting because it had to be large enough to be meaningful to help reduce these barriers, but it couldn't be so large that it would be unaffordable and detract from our primary missions here at NASA. So that was a number that was settled on. There wasn't a great deal of analysis behind that number. People ask me a lot, where did the 500 come from, and was there a lot of modeling done and mathematical analysis? It really wasn't that much, although when we started formulating the program, we did run the models, and we believed that that amount of money should result in more than one company, our ability to invest in more than one company. And that was really important to us. We didn't want a grant. We didn't want to hand out a grant to one company. We wanted multiple companies trying to achieve these goals. And there are a lot of good reasons for that. So Mike offered the $500 million and a commitment that prove it and we'll buy it. And that was the foundation for what became COTS. So later in that year, 2005, I had been working on the space station for almost 20 years, and I did various things. I ended up being the configuration manager for space station, and I also worked a lot with of course, change management and contract management and technical management and coder work and things like that. So I think that's how I landed this job, because having the experience with space station, understanding how the contracts work, and then being able to put together a new program to help service the space station, I think was a real good fit. So late in 2005, I put my team together, and we started putting the foundations of COTS. We're going to talk about some of the key elements of COTS that I think make this different than any other standard acquisition or procurement process. We'll get to that charts in just a minute. But very quickly, in a matter of 4 months, we put the program together, put the and the announcement for proposals, and we awarded the first round of partners in 2006 and the second round with Orbital in 2008. So why don't we take a look at the video and see what amazing machines these companies developed. We don't get it down there. This was the first COTS demo from SpaceX. It's first flight of it was the second flight of the Falcon 9, but the first COTS demo on in December of 2010. And this was a quick demonstration, 2 revolutions, and then it returned. First time the Dragon capsule returned to Earth. Then in May of 2012 was the COTS demonstration to the space station. There was demonstration cargo aboard the Dragon. Supposed to be 2 demonstration flights before getting to the space station, but SpaceX accelerated their work and did their entire demonstration in one mission. Of course, after about 5 or 6 days on orbit, it came back and successfully demonstrated that it could also return cargo. All right, our second partner, Orbital. They saw the first launch of the Antares vehicle in April of 2013. And then just last September, this was the demo flight to the station. They had a little hiccup on the way with a little data mismatch in the GPS system, but actually proved out the ability of Cygnus to be able to loiter on orbit for a while. And that will be useful in upcoming missions if they want to launch early and wait on orbit until the station's ready to receive them. Well, that capability was demonstrated too on this mission. Orbital also carried up some demonstration cargo, about 1,500 pounds. And they loaded it pretty full coming back for the trash and the cargo that they needed disposed. It was on orbit for about 30 days. It was released on September 22nd, and then a day later.
Cygnus bids farewell to the International Space Station. Release confirmed at 6:31 a.m. Central Time. Once again, the 2 vehicles were high above the Atlantic Ocean.
and it had a safe, uneventful reentry. That's a look at the hardware and the systems that emerged from this capability. Certainly couldn't be any happier with the outcome. All right, so let's see. Why don't we get into the charts here, and we'll talk about some of the unique elements of the program. Am I hitting the right button, Dave? This, the top one?
Oh, yeah.
Where am I pointing? To the machine over here? Did you do that or did I?
I did that.
Oh. Okay. All right, so we'll talk about the COTS, the SpaceX and Orbital, and then I'll speak to the lessons learned from the program, and then I'll turn it over to my project executives to give some perspectives of what we learned from working with the companies. I mean, this was definitely a two-way learning here. Companies were certainly benefiting from the resources available from NASA, and we learned a lot on how these companies can work in such a lean and agile manner. Okay. All right, so this is just the summary slide for SpaceX. The agreement was awarded in August of 2006. That first round competition was very healthy competition. There were over 20 companies that proposed in this round. We down selected to 6 companies who had very strong proposals. We did due diligence with these 6 companies, and that was a new term for us. NASA had to learn how to ask for a business plan and then evaluate a business plan, and that's something we don't typically do in such detail when we do our acquisitions and procurements. We know how to evaluate mission suitability and technical merits of the proposal very, very well. But learning how to evaluate a business plan was something pretty new for us. So we hired a venture capitalist. We knew that was going to be very important to understand that dimension of the program. So there was a gentleman by the name of Alan Marty, who was CFO for Hewlett-Packard. He was an entrepreneur himself, and he did a lot of consulting work with Ames in helping them with business propositions and partnerships at Ames. So he was very, very useful to us. So we brought him on board, and he did a lot of coaching and mentoring for us on how to look at these proposals and evaluate the plan. The whole evaluation process was different. I'm not going to go into that right now, but these were proposals that you couldn't score. If you've ever been involved in a source board or evaluating proposals, typically you look at the mission suitability, past performance, and management team, and you can score the proposals against a fixed set of requirements. Well, we didn't have a fixed set of requirements in the announcement. There were just goals and objectives. These were outcomes we would like to see, but we didn't specify exactly how the systems were to perform or the capabilities or the sizing of the systems or things like that. So we couldn't possibly score proposals on an equal basis. So rather than scoring them, we came up with levels of confidence. That's how we were rating the proposals that we were evaluating. We looked at the technical approach and the business plan and assigned a color rating from blue being very high confidence, green high, white moderate, and then yellow for low and red for very low level of confidence. And that's how we differentiated between the different proposals. Because they had different capabilities, different requirements, different merits. I think that proved to be very, very effective for us. But that's how we discriminated between these 20-some different proposals by level of confidence, primarily. And then we looked at the cost. What is it that they proposed the cost would be to complete the demonstration, and then how much were they asking from NASA? We told them we had $500 million, but we did not tell them how much we would offer each of the companies. It was their strategy to decide how they would fit within our portfolio of our investment of $500 million. Some companies asked for all of it. Some companies asked for very little of it and different strategies. And then some knew that there was going to be something in the middle, that we wanted at least two different companies. And that was closer to the right answer, being able to split this up. Okay, so we did that round, and in 2006 we awarded 2 Space Act agreements, one to SpaceX and one to Rocket Plane Kistler. The original value was let's see, 200, what was the original? 278 was the total of milestone payments to SpaceX. And then Rocket Plane Kistler was 206, and then we kept just a little bit. 3% of the entire program's budget was kept for the program. So that meant 97% of all the program funds were going to be distributed to these companies, because that was the primary purpose, to help remove that financial barrier. So we from the beginning, we had a very, very small amount that we kept available to run the program, and also to reach back with NASA technical resources to help the companies we needed. All right, so and then I'm going to talk about this a little bit more. In 2010 and incorporated in 2011, we did receive an extra $300 million appropriation from Congress, which we distributed to our 2 partners with additional milestones. And we used that money to add milestones to reduce risk in the program. Because at this point, the companies were quite far along, and NASA decided that we were dependent on these companies to fulfill these resupply needs for the space station. So it was decided that we were asked, what could we do to help assure the success of the program in these companies? And the best thing we could do was add in additional testing, ground testing, flight testing, to increase the confidence in the systems. So that's what we asked for, and that's what we received, and that's what we did in 2011 by adding another series of milestones. SpaceX, of course, developed a brand new EELV class launch vehicle, a brand new autonomous state-of-the-art Dragon spacecraft capable of carrying cargo to and from the space station, and a brand new launch facility. I mean, it was, like I say, modified facility at the Cape, and but pretty much you you took a slab and put it together. So those are the key elements of the SpaceX system. Where's Dave?
Is the wheel on the side?
Just point
Okay.
it at me and I'll do it.
Okay. All right. So we saw in the video, those were the 2 demonstration flights. I think it's worth noting that the original plan was for 3 demonstration flights. And that we saw that as a big plus, by the way, when we were evaluating these proposals. For a company to be able to propose 3 separate space flights on 3 separate vehicles was a huge plus. I mean, we were only giving them $276 million. And to us, that represented 3 attempts. Now, honestly, when we were looking at this, we didn't believe all 3 would be successful. The history shows that for new launch vehicles, the chances are they're going to have a problem in the first, especially in the first 3 flights. So we thought that was a real bonus, that we would at least have 3 attempts at getting a successful flight. And in the end, they ended up combining the because the first couple flights of Falcon went very well. The demonstration of the Dragon reentry went well. So now it was just a matter of putting the systems together to do the rendezvous and berthing and completing the integration with the ISS. So they took a little extra time to do that, and of course that worked out very well too.
Where you want to go?
I'm hitting every button I can find. So thanks, Frank. Okay, so we saw in the video the highlights there. We can go to the next one, Frank. You can just,
I'll just stay here.
yeah, thank you.
Might make more sense.
All right. Now, this is the series of milestones that were negotiated in the Space Act Agreement. I think the milestones were very, very key because they were pay-for-performance milestones. We were not going to hand out $1 until there was some objective measure of progress all along the way. So this required companies to raise the capital up front, perform the work, and then get reimbursed for the work. That's not typically done. Typically, in a development program like this, we pay the cost, pay the fee, and we pay up front. But that's not the way this was set up. I know you probably can't read that, but they are available. I think...
We're a full-service provider.
Yeah, with NASA water. Okay. So this chart shows several things. The solid blue diamonds represent the actual performance of the milestones. They were originally laid out with solid blue outline triangles there. So where you see them concurrent is where the milestone was executed exactly as planned. Now, you can see in some of the later milestones coming up to the flight demonstrations that there was a delay from the original plan into the actual execution. Now, there were very few modifications made to these Space Act agreements. I'm accustomed to contracts that have a lot of changes. For one reason or another, we change our contracts. And every time you change the contract, you do a negotiation, you pay the cost, you pay the fee, and these are pricey. We had, first of all, very few modifications. I think maybe a total of 7 or 8. Most of them were administrative. And we did not change the schedule much. I mean, even if the companies were running behind, we did not change the milestone. The only time we did that is if we came to an agreement that there was a replan necessary because, it was NASA's preference to move a milestone for one reason or another. And we did that up front just for a couple month thing, just because we wanted to save a trip and just save a little money. So, I mean, that was kind of administrative. But then when it came time to combine the two flights, we agreed to that because we knew that was a good plan, and then we were able to replan some of the milestones. So we were not very generous changing the schedule. If they were late, they were late, and our goal was to make sure that they were making sufficient progress such that we should stick with the agreement and let this play out. So what you'll see here is the actual performance of the program, how the milestones were performed, what the original plan was, what the replan was, and then how it actually ended up.
My assistant.
All right, and then this is the separate set of milestones that we implemented in 2011 with SpaceX. And you could see they were performed pretty much right on plan. Now, this included things such as additional system-level ground testing. Now, we know here at NASA how important that is, and we put a great deal of emphasis on our system-level ground tests. And when we negotiated the initial agreement, SpaceX had a number of tests in there that had to be pulled out because we didn't have the funding available to support that level of work. And with the resources they had available, we had to strike that right balance. So in place of doing high fidelity, full-up system-level tests in some cases, we recognized that the fact that they were doing 3 flight tests really would fulfill that need to do testing. I mean, they were going to do flight testing instead of ground testing because they were cheap enough. They were able to do it. So we bought into that. We said, okay, that is a strategy that's acceptable to us. But then when we were fortunate enough to get this extra appropriation, there were certain things that we added. We suggested be added back in, like full EMI testing, thermal testing, and that EMI testing proved to be very, very useful. I think Gwen can talk a little bit more about that, but there were definite issues uncovered during the test that very likely could have caused an abort in the demonstration mission if those systems weren't upgraded and issues weren't worked out. So I think that paid dividends, very strong dividends for this investment in ground testing. Okay, let's move on to Orbital. Okay, you saw in the video. Here again, we're getting a brand new liquid-propelled medium-class booster, a new autonomous spacecraft, and using a new launch facility out of Wallops Island. Now, this was a partnership in so many different dimensions. I mean, this was a completely different approach. SpaceX building most everything they could in-house, and then Orbital, a larger company, drawing upon the expertise, heritage, and resources available in industry around the world, and putting it together in a more cost-effective manner. That was their approach. So that was part of our strategy, to have 2 different approaches: an in-house, smaller startup company, and then a larger, more established company with heritage technology. That's how we balance some of the risk in the program. Certainly the ability to have a portfolio was a big risk reduction, just having more than one company. And then the different approaches was a different strategy we used too. So SpaceX Orbital, pulling from the first stage core from the Ukraine, and second stage was from ATK with its solid motor second stage. And then drawing upon the heritage of the pressurized cargo module, right from the Italians, who built our MPLMs for the space station and other pressurized modules for the space station. So they had a great deal of heritage dealing directly with the station. So obviously that was a great fit to take that technology, put it on a service module, and then have that be the vehicle, the resupply vehicle. So we saw a lot of strength in that. And then they partnered with the state of Virginia in using the Mars Mid-Atlantic Regional Spaceport, and Bruce can talk some more about that, because that there was a great deal of utility in partnering with other government agencies and leveraging funding and resources in that manner. So Bruce can talk a little bit more about that. Next chart. Okay, we saw again two flights, two very successful first flights for new rocket. Next. Frank can talk about the little GPS issue if you'd like to hear some more about that. But overall, it just goes to prove, out of all the thousands and thousands of things that have to go right, one little line of code can go wrong and abort the entire mission. We weren't able to fix it.
Not the entire mission. It's really more of a pause than an abort. So.
Well,
They didn't abort the whole mission.
no, but could have. Could have, if you didn't fix it. Okay, so here's a look at the orbital milestones. Again, you could see the original plan, then we had a replan, and how that was performed against the plan. Now, there were delays. This is human spaceflight business, and I don't think any of us in our agency or here in the room would deny that this is such a complex business that certain amount of delays are inevitable. You're going to find problems. You have to fix the problems. That is the real measure of success, being able to find the problems, fix the problems, and move on and get the job done. So we recognized that from the very beginning. When we looked at these initial schedules, our team, of course, we're skeptical that would be able to be achieved early on, but rather than convincing these companies that they should extend the schedule, we said, okay, be aggressive, try your best, and we will be patient and reasonable when you hit a problem, and not trigger happy to cancel the agreement and be done with it. I mean, as long as we were seeing steady progress, well, then that was the measure of success for us. But here's the history on that. Next. And then this is the set of augmentation milestones for Orbital, and this consisted primarily of adding back in a maiden flight demonstration. We very much wanted to do that when we negotiated the initial agreement, but we just didn't have the funds available. So this was a very prudent use of that additional funding. Next chart. Okay, so let me step through some of the things that I think are unique from the program aspect. Certainly our government money was highly leveraged. The companies can talk some more specifics about that if you'd like to hear, but in the end, these companies contributed more than 50% of the total cost of the development. So I think that's the primary emphasis here. We set out not to pay the total cost of the development, but become an investor. We had to learn to think like an investor. And they had to learn to treat us like an investor, a principal investor who would sit at the table and otherwise be taking probably a good healthy chunk of equity in the company and having a role on the board of directors and things like that. Well, we didn't do that. So we were their ideal investor, I think. We didn't take any of that. All we wanted them to do was be successful. I'll never forget sitting at the table. All we want is for you to be successful, is what we would say. To negotiate the milestones. So I think that's a very key point. This is high leveraged money. So what became very important, though, also is their ability to finance the job. And we saw with RPK, if you cannot finance it, and that was the reason why we had to terminate our agreement with RPK, well, then it wasn't going to work. So certainly it was highly leveraged. Financing is very important. I think the fixed price milestone payments, absolutely, it provided the maximum incentive to control cost and schedule. These companies were not going to get paid unless they performed the work, so they had all the incentive in the world to perform it as quickly as they could. And then they wouldn't even begin to recoup any of their investment cost until they sold their services to NASA and other customers. So, of course, they were driven to get to that operational phase as quickly as they could, too. So, milestones, very powerful. Cost, because we weren't going to pay any overrun. They were fixed price, and schedule. They had to perform in order to get paid. Now, I think the third bullet speaks to requirements. You're going to hear some opinions from me now. I usually talk facts and figures, but now I've been given the opportunity to talk about some opinions at the end of the program. And now that it's successful, I'm willing to share my opinions with you. I think the requirements are such a key factor in driving the cost of our programs. I thought a lot about this, and most of the NASA workforce is obligated to verify the requirements that we impose on our contractor. That is our job. We must be assured that they are performing against our requirements. So requirements are a big driver, and in this case, we absolutely tried to minimize requirements. The whole program was built upon maximizing innovation and flexibility so that the companies can take advantage of their approaches with minimum cost. So in our announcement and in our Space Act agreement, you will not find any firm requirements for the performance of this system. In the announcement, it ended up being 2 pages. Capability A, B, C, and D. External cargo, pressurized cargo, return cargo, and then crew, eventually crew. Those were the 4 different capabilities. And then we wrote a paragraph on each of those capabilities that said, well, we might be able to handle something like 2 to 8 flights a year. I mean, there was certainly a rate that we had to specify because they couldn't be coming up every week. There's too much traffic. So if they had a very small payload capability, companies would want to deliver more often, but that wasn't going to work. And then we needed it more than once a year because of the nature of our research and turnaround of cargo needs and things like that. So we gave them a range of traffic rate, a range of what we believed would be our need for cargo. And that was to help them size their business model. We knew that in order for them to complete their model, they needed to have some idea of what our interest would be as a customer. So we did that in terms of goals and objectives. That's what I'll call them. And if they deviated from, that was okay, as long as there was a good rationale for what they did. And that's how we evaluated. We wrote it up, strengths or weaknesses against those goals and objectives. And that helped us assign a level of confidence. How well did they meet our goals, and what was the likelihood? It was sort of like an inverse risk matrix. Here was our goals, here was the likelihood, and then we ended up with a color rating somewhere based on that approach. Except when it came to the space station. That was the only set of firm requirements, because obviously we had to assure the safety of our crew and our assets. And we were not interested in redesigning the physical interfaces or the data interfaces with the space station. They've been designed. So those became the only real firm set of requirements were the interfaces with the space station. And in order to make that user-friendly, we consolidated all those hundreds of documents that defined the space station interfaces that evolved over the years into one set, one interface requirements document, because we knew that would be very helpful to these companies, and I think that went a long way to helping speed this along and reduce time and cost. So my thoughts on requirements. Okay, the next one is talking about portfolio of partners with different capabilities with a balanced approach. There's so much goodness in that, so much goodness in having multiple companies striving to achieve these goals. Intrinsic things like market forces. There's good, healthy competition. Companies are proud of their work, and they're proud of their product. And this was like anything else in America where you're bringing a new product to market. You have to be the best or the first, depending if you're trying to create a new market or capture a share of an existing market. And this was a little of both. These companies were trying to take back a share of the launch services market, which meant they had to be primarily lower cost, high reliability. Lower cost is going to capture share back. And then new markets of having a transportation system to a destination. That was completely new. We've never done that before. Yes, we've had commercial launch services. Yes, there's a thriving multi-billion-dollar communication satellite market, but actually taking cargo to a human transportation, a human destination, and back, that was new. So I think the portfolio was very important. I think balancing the risk between established small companies, the more we could get, the better it would be. It's just that with the money we had available, I think this was a good mix with these two companies. Also, we were able to focus on different capabilities. SpaceX had the ability to bring cargo back, and they had the ability to bring external cargo in a trunk. Orbital has the ability to have a much larger volume. So all that cargo that's less dense, could pack it into a larger volume, and then the ability to carry that much more volume and for the trash that needs to be disposed. So there was a lot of goodness in the different approaches, and having more companies gave us more capabilities too. So I think that was a real element of goodness. And then we can talk about some of the specifics in the terms of the agreement. Everything we did was written to be commercial friendly. And the beauty of the Space Act Agreement was it allowed us to craft every single clause in the agreement. There were no standard FAR clauses. There were no standard requirements for typical government procurement. Every one of them was able to be specially crafted to meet the objectives of this partnership. And I think one of them was not having to have termination liability for, or a termination for convenience. We didn't put that in this agreement because we expected the companies to raise money to complete the program, either from internal sources or external. And in order to put that commitment, to get that commitment from a company, we just couldn't walk away for any reason. So we didn't put that in there. The only way we were going to terminate this agreement was if they didn't perform or if we didn't get our annual appropriation. I mean, that's the government. That's just the way it is. There's nothing we could do about that. But if we lost interest, no, that we were not going to walk away. Didn't allow for that. So I think that helped companies become more confident that they could use their corporate resources and invest in this with confidence, knowing that we were going to stick it out as long as they were performing. And then the other thing was intellectual property and data rights, where to the maximum extent allowed by law, we gave them the rights so that they could turn around and sell these services and make a profit and expand and grow the U.S. Space industry. And that's exactly what we wanted to do. We did not want to take it. So we worked very closely with the lawyers to give maximum rights to these companies so that they could turn around and make a profit on it. I think it's very, very useful. Okay, next chart. Other way. So this next chart speaks to the market that I think is a very key element. Companies aren't going to invest time, effort, and money into a large project like this unless there's the ability to make a return on that investment. So NASA being a primary customer with a very, very healthy market with the space station was huge to this. The problem was we could not commit to that. At the time we were making the deals, the companies wanted so much for us to say, well, if we do it, will you guarantee us that you will be our customer? Well, we could not do that. We could not. You know the government. We cannot obligate the government to future commitments without going through the due process. Competitive process, the FAR process, and getting the appropriate appropriations to fund it. And we did not have that 6, 7, 8 years ago when we were doing these agreements. So all we could do is say we're committed to it. And we made that commitment, and it was a promise, but it wasn't an obligation. Some companies weren't good, that wasn't good enough for some companies. Some companies just could not close the deal with just a commitment, especially the companies that went to Wall Street and tried to raise the money. Those guys wanted the deal. And that's just something we couldn't do. So I think we need to think about that a little bit more, how we can kind of strengthen that commitment. We probably need to think about that a little more. Not saying obligate the government to something we can't do, but maybe make those promises a little stronger somehow. Maybe it would be if the companies were successful in demonstrating that they would become eligible for the service contract, whereas those companies that didn't demonstrate would not be eligible. Something like that. Something that would give them an advantage to the service. I think we need to think about that a little more. And then this next bullet on here is just something we stumbled on. We were so happy with the way we crafted the Space Act Agreement and all the terms and conditions, and we even contemplating giving some equipment to the companies to help facilitate the rendezvous and berthing with the space station, because we really didn't want them to reinvent that wheel. Oh, that was a lot of work with the ATV and the HTV. And it took 10 years or so integrating those systems. And that's something we just did not really want to go through again. So we were expecting that we might have to GFE the entire rendezvous and ProxOps system. We didn't end up doing that, but it is something we contemplated. But we did have some spare CBMs, the berthing mechanisms. And this was a long lead item that these companies certainly could have used. And we had to go through hoops to get them the CBMs, because you just are not allowed to GFE equipment under the Space Act Agreement. So we got to work on that. And then we talked about the augmentation funding. I think that was certainly a great bonus to the program. We didn't expect it. I think it paid huge dividends. Having that extra investment to reduce the risk led to the successful program. And the problem is, though, you wouldn't know how to plan for that early on. Early on, when we had $500 million, I couldn't say, let's reserve $300 million for risk reduction late in the program. You just wouldn't know how to carve that out. So it was a good thing, but it would be hard to plan for early on, I think. And then finally, I would say it worked. It worked. This was an experiment. Could we do it? Investment, technical resources, and help as needed. Could it lead to a new space system? Well, companies proved that it did. All right, so I've spoken enough, and I'm going to turn it over now to Mike, and he's going to tell you some lessons we learned.
Okay. Well, there was certainly a lot of learning that went on over the roughly 6-year development program on both sides. I'm not going to get into a lot of the reach back into NASA technical experts that I managed to do to help SpaceX along the way, and then just learning how to do business with them. But what I'm going to try and focus on are some key areas that I think the agency can use on future programs. One of the first ones is design, test, and repeat. I think too often the agency, when we get into a budget crunch, we start cutting out the engineering units in development programs. And quite frankly, you learn a lot from those early development units that you don't learn by just doing a lot more analysis. And for a commercial company to recognize this seems to indicate something to me that NASA should learn not to cut those engineering units out of early development programs, because those iterations in the design makes for a much better product and a lot less pain at the end of the program when things aren't quite working right and you have a whole bunch of operational fixes that you have to deal with. So I think that was a key lesson learned. Use of COTS electronic parts is feasible instead of all S-level parts through the use of some radiation screening, some analysis, some testing, and some architectural decisions on how to implement redundancy and some reboot capabilities. I mean, space station has flown laptops on the space station for years and years, so there's commercial parts, electronic part history of being used in spaceflight, but SpaceX took it to a whole different level. And I think there's significant cost and schedule savings that can be achieved for a project by using more of a commercial avionics and software approach. Early in my career, I did some Phase A studies, some Phase B studies, and I did a lot of cost modeling, GE price models. And I think the agency can learn a lot in how to do things faster by using commercial avionics. I mean, if you can save 6 months or a year off the overall development cycle on a program, you don't just save the cost of that avionics box, you save the cost of the standing army that's around for another 6 months or a year, which can be a big deal for a project. And you just get to turn projects around faster and do things for the agency quicker. The other thing that was refreshing to me, I think, was that they designed with cost in mind from the very beginning. When I had initial discussions, we had weekly telecons, and we'd talk about, parts that would need to be used for common interfaces, and this is the typical vendor that we used. And SpaceX would hear that, go get a ROM quote from that vendor and go, this is way too much money for this part. I mean, everything that we touched, their first thought was, how much does that cost? And is there a way to do it cheaper? And if it was too expensive to get it from a subcontractor, they brought it in-house and built it in-house to try and make it cheaper. Just having that conscious thought in mind at the beginning of the design cycle, I think changes the mindset and the cost of the overall program compared to what we typically do, which is make sure that it works. And, it doesn't matter what the cost is, as long as we're absolutely positive it's going to be a working, functioning unit and meet all the requirements. It has a much different mindset when you keep in mind that cost is a critical element in the design process. So that was really refreshing to me. And in some cases, SpaceX just brought the parts in-house and didn't have the sub-tiered vendors, so there was a layer of cost that they didn't have to deal with. And it had the added benefit of letting them iterate the designs quickly because they didn't have to deal with a bunch of contracts and subcontracts. And there's big advantages there that I think the agency can learn from, whether it's looking at new contracting mechanisms to be able to deal with sub-tiered vendors, or learning how to do more stuff in-house. I don't know. Then the last lesson was we observed their use of, let's say, wiki tools for multiple critical business and engineering processes, and it saved them a lot of time, and it helped them move to a paperless environment. They used a lot of SharePoint, and I think Confluence now is their primary tool for just sharing general information to the whole company and the program. That helps a lot, so you don't have to have as many big meetings. We also worked with them to not require as much paperwork being delivered in some cases. An example might be instead of a large structural analysis report, we let them deliver the actual finite element model and a summary level report. So we didn't create as much paper, but we got all the insight that we wanted into the design and where the critical factors were in the hardware by delivering more electronic database information instead of the typical large paper reports. And then they use something called track tickets to deal with issues, changes, and risks for many of their teams. And this is sort of a online, almost like a wiki page, where you'd list the issue, and then whoever initiated the issue would start writing in what the issue was and what they were going to try and do to fix it. It get distributed out to all the required reviewers. They'd quickly be able to comment into that ticket, whether they had a question or add some more information about this other thing, and you'd get a running history of the issue and the problem, and you wouldn't actually have to have a board meeting in a lot of cases to deal with a lot of these issues or risks. And you had a continuous history of all the questions and things that went on related to that issue. I remember this worked really well on the first COTS mission. We had an issue that came up very late in the program, actually out on the pad, where the nozzle on the second stage had a crack that had formed, and we needed to understand what could we do with it. Did we have to change out that nozzle extension, or was there a way to still use the vehicle? And SpaceX had proposed cutting off the extension because they didn't need the performance on that first mission. They had documented all that history and all the analysis that they had done in one of these issue tickets, and we were able to review all that history as well as send it up to headquarters and get headquarters to understand that there was a lot of analysis that went behind this decision, and it wasn't just a off-the-cuff, last-minute, in the launch fever decision. And then we proceeded to launch with that history and backup and paper to kind of cover us, and it worked flawlessly. So there was, and that all happened in the matter of just a couple of days, not the typical, you got to go to this board, then you have to go to another board 2 weeks later. Yeah, it was about 2 days. So there's a lot of advantages to that, as well as letting the teams look at some of these issues on their time, as opposed to having it pre-scheduled on a certain board and on a certain day. So I think we can learn from that. The only caution I have is if it gets to be a very tricky problem, sometimes you need to just pick up the phone or call a meeting and actually discuss it. Sometimes you can get bogged down into a little bit of a do loop with just the paper trail. So be quick to schedule a meeting or pick up the phone if it's looking like it's getting bogged down. I think that's about it.
Okay.
Bruce?
Yep. I'll talk a little bit about some of the things we learned working with Orbital. We're going to talk not only some of the structural, technical kind of things, but some cultural kind of stuff about how we work and play well together. It's not organized as cleanly as into those lines, but we'll hit a couple of different points. The design review process. One of the really interesting things that I saw when we were working with Orbital is their utilization of independent review teams that would come in periodically into the program and really review the program from top to bottom. And that team was typically made up of the more experienced set of folks, outsiders that came in, brought in as consultants to the company, and they look at the program from top to bottom. NASA does some similar things to this, but not always in the same mechanism. They would look periodically at different points. They had really inputs right up to the point of participating in the flight readiness review system process. And they weren't bound by cost and schedule, and were really based their inputs on their technical background, their technical experience, their programmatic experience of what was good, sound judgment. And then the inputs typically went to a layer of management above the guys who were actually executing. So it gave the higher levels in the organization, the company, the opportunity to understand whether or not they're on the right path and get sort of balanced, validated design decisions and programmatic decisions. But a couple of pieces of that, the team needs to be consistent. You don't want to be slipping people in and out constantly. They try to keep the same team together from the beginning through the end. Now, obviously, sometimes there's changes and people, for a lot of different reasons, have come on and off, but it was a conscious decision to try to keep those folks consistent and on that. Standard building block designs. NASA frequently, or almost always, designs everything from the ground up, uses completely custom pieces, whether it's the part level, the architecture level, the system level. When you look at the way commercial industry works, they talk about things like families of launch vehicles. And there's pieces that flow from each launch vehicle or each satellite that are common. Now, that doesn't come without risk. There's NASA lessons learned that talk about wanting to avoid some of that at sometimes, but it does lower a lot of the technical risk. You end up having a lot of inherent knowledge in what the designs are going to be like. So it can help lower your long-term technical pieces to it. It doesn't necessarily lower the cost, because if you have to qualify the system, it's got to qualify. You got to test the whole thing. But it does give you opportunities that if you know that in fact it's been bound by previous experience, you can take advantage of that and leverage that. Again, it does come. It's not a free lunch. There is risk of that, where you may anticipate being able to take advantage of things that you couldn't, in fact, do. So you need to be careful at it, but it can be a very powerful tool. Leveraging common goals amongst the constituents. This is something that NASA typically we, when NASA comes into a program, we pay for it all. In industry, they look for synergies that we don't always realize are out there. And I'll use the example of the creation of the where they ultimately launched from at the Mars range at Wallops. Orbital wanted to resupply the space station. State of Virginia really has no interest in resupplying a space station, but they did want to have, they did want to create a launch capability to launch larger rockets from their soil. So that became, they had overlapping interests there. State of Virginia's goal isn't even really to launch things; it's to employ people. So ultimately, they were willing to put money into it to create infrastructure that could be used for other programs and other entities. So they partnered up with Orbital on creating all that. Again, if you look at how we've created things and create the infrastructure, NASA tends to do it all, and own it all, and pay for it all in the end. So there are opportunities to leverage other people's interests and partner in ways that maybe we didn't always traditionally think about. Next thing I'm going to talk a little bit about on the next slide was that NASA is more of a cultural thing. If NASA can embrace a sort of a cultural shift and working with the partners, there's an awful lot of advantages to be found on both sides of the fence. NASA has an immense technical capability, but we don't always take into consideration the constraints that companies have, which are principally usually cost and schedule. We tend to be wanting to grade things. We tend to want to say, yes, that passes, that fails, that's it. If we get into a mode, and this is one of the things that I worked really hard with working with when we would draw technical folks from the centers, is if we take into consideration the constraints the partners are taking and help them with the designs, there's an awful lot of benefits. Industry, that will open up. If we show value, we show we're trying to help them, and that we're not sitting back and simply saying pass, fail. They will open up, and they will want to leverage and utilize that capability. But it does become it's a cultural shift. It's a thought process and a mind set that is different when working with the entities in this way. You're working with them. It's not oversight. It's not even, in my mind, insight. It's trying to work and figure out how we can help each other get down the road. Communication and all these things, and this is something that it's communication and trust is absolutely essential. When we tried to work with Orbital, and before that RPK, we were partners. I never wanted to be viewed as a customer. I never wanted to be viewed as them to be viewed as a supplier. We were always trying to work things together. Regular tag-ups, talk early, talk often, was an absolute key to that. It really was. It's a relationship that needs to be built to last. It's got to be nurtured. You've got to build it as if it was a friendship or a marriage, because the reality is, if things work out and they're successful, we're ultimately working this thing in the long haul. Not only just the development phase, but in the operations phase and the whole execution of the program. Now, in a lot of ways, we're married with Orbital and SpaceX. That we're going to through the life of the CRS contract. So where we started off on an effort to try to do a couple-year development program, now we're working on an 8 to 10-year effort. So you really need to nurture those relationships. The last thing I'm going to talk about is a little odd and a little vague, partially by design. Breaking interfaces and systems that are not designed for multi-party uses can be really challenging. As we all know, Orbital did have a software issue as they approached up the space station. A lot of that was based on the fact that the systems that we were utilizing, some of the proc systems that were produced originally designed and used for the HTV, the interfaces were there. We were really breaking into and getting involved with things that the Japanese had put together with the intent of using with other Japanese systems that would then touch the space station. Well, we offered that up as NASA offered that up as something that the partners could use, but it really involved Orbital then getting involved very intimately into systems that the Japanese had designed, that then had to operate very intimately in with their systems, and very intimately with the International Space Station systems. It's a challenge. It worked out. We did find a flaw initially, but it's important to lay in flexibility with the system. Not only that, when we were first starting this, there were a lot of discussions about whether or not you'd ever need to do a software reset on orbit. Clearly, software resets and that flexibility that was put into the system was key to that success. So there was a lot of. it can be a challenge to try to break some of those systems and break some of those interfaces, but it's not impossible to do. You got to think clearly. You want to ground test as much as you possibly can, but leaving some flexibility to the end on orbit is key. So those were the things that I wanted to highlight, and pass it over to.
Okay, Frank, you want to?
Do we need to save time for questions, Alan?
What do you want to do, Dan?
I think each part go for 6-7 minutes. We're good till 10:10 or 11:10.
Okay. Well, first of all, Alan, Bruce, Mike, thanks very much for the words today. I think it's been a very good description of a long, challenging program, and both we and SpaceX have learned a lot along the way. But I think NASA has learned along the way, too. And as you said, in pointing out your lessons learned, they are important. And my screen just timed out, so I lost my notes. But the best thing, I think, was the fact that you didn't come in and overpower us or outman us or suffocate us in any way. Not that NASA would ever do those things, but what a lot of us have learned along the way, whether you were on the NASA side or on the industry side, you kind of have to play man on man with the people that are important to the program and the customer side from industry. And between you, Alan, and Bruce, and Kevin, and a handful of people from the ISS, we had a good, tight team to deal with. And it was a very consistent team that didn't change very much, and so we always knew where you were coming from. The communication that Bruce talked about was key, and the ability of you all to listen to us, particularly early in the program when we were trying to learn what really is our relationship and what do we have to do to provide this service to you. It was more than just make you happy. It was the ability to satisfy our requirements in a way that they met your requirements ultimately. And eventually, we all reached an agreement that we own the system. We make the decisions, and if we make the wrong decision, we may not be able to provide the service that you're looking for in the long term or complete the demos. And so we had to take responsibility for what we did. You all were very good about giving us advice when we asked for it, and you were good about backing off when we needed you to let us work things out for ourselves. And I think that was proven when we got close to the station and had to go around and try again, that we had a good relationship established that allowed us to work together with trust and eventually get to the point where we could safely complete the rendezvous, and everybody was satisfied that it was going to work out because our teams knew each other very well. That's how we get to a long-term service arrangement that will allow us to do these things in a fixed price environment. And that's another key element here is a lot of us have experience with cost plus in the NASA environment, and we know how that can lead to cost increases. It can lead to misunderstandings. It can lead to people doing things that some NASA engineer said, I sure wish this thing was red. And then somebody goes and paints it red, and then who's going to pay for it? These are the kind of things that we were able to avoid by going into a fixed price environment. It also puts the challenge on us to control our costs very tightly and make sure that someday we might make a profit on this and turn it into a service that can last for a long, long time, cost effectively for NASA. You mentioned the investment by the state, by NASA. NASA did increase their capabilities at Wallops to allow us to do this. It can be used by anybody who comes there, of course. But the fact that we had such a good working relationship between the various entities was testimony to, again, the commitment to everybody to making this service work. The state did invest in it significantly, and they're going to benefit for the long term. As you mentioned, software is usually your biggest challenge. It turned out to be one of our biggest challenges, in addition to getting the pad completed. And I think that's a lessons learned we have to look for in any program, is that you always need to pay a lot of attention to how much you're investing in the software early on, and do you really understand the requirements. You had very clear requirements for us when we were near the station. That was a new level of expertise that Orbital had to develop that's different than our commercial geo satellites and even our science satellites. And so we had to step up our game, and it was valuable to be able to do that hand in hand with the folks at JSC and other places who allowed us to talk to them and to use their facilities for testing. So in summary, I want to say that the other thing was having that contract out there in front of us as a strong possibility at the very beginning allowed the company to actually begin investment in the Antares before we even had the Space Act agreement, and then to commit to the COTS program with the ability, knowing that we would have a chance to compete for that. And then once that contract was signed, I think both companies gained a lot of confidence that it really is worth all this effort and investment to keep it going. And so we're looking forward very much to continuing that as long as the station is flying. I want to thank everybody on the team for all the hard work to help us get to where we are. I'm very proud of the folks on my side also, and we're looking forward to our next flight in December and after that in April, and just continuing to carry as much cargo as we can pack in to keep the station going for a long, long time, Alan. All right, thanks.
I've learned that when you go last, you tend to be very redundant in your remarks. Probably 4 or 5 things that I think are worthy of note when it comes to lessons learned on this program. And fundamentally, I think they're rooted in 2 primary things, and that is firm fixed price contracts. Very critical in this kind of environment, coupled with a partnership. The relationship and trust was key here. So what falls out of those 2 things? NASA gave us enormous flexibility to do what we needed to do the way we could best accomplish things. They never told us the hows, but they told us the whats. And what's critical is the whats that we had to accomplish, those very specific requirements that had primarily to do with ISS safety. They were stable, they were well established. They were stable. They were pretty well communicated up front. There were very few surprises, a couple here and there, misunderstandings here and there, but they remained stable. And that's key in a firm fixed price environment. As Frank says, if someone says, well, I think that system should be red instead of blue, in a firm fixed price environment, in a partnership environment, there's the openness and the willingness to say, you know what, blue is fine. It's okay to be blue, or it's easy to push back on changes, desired changes, when you have this whole program construct the way it was laid out. I don't know if it was on purpose, but it sounds like there was a lot of thought that went into the philosophy of COTS. And frankly, I think it was necessary to have all of those elements present to make this program the success that it was. Critically, as Frank also mentioned, the services portion, though I think that had less play for SpaceX early on, this was something that we really wanted to do to move forward towards our vision and to move forward in why we were founded in 2002. But there's no question that the hope of the services contract and the fact that that came earlier than we had originally anticipated was enormously helpful for us to continue the investment that we made in this program. And ultimately, it's enormous success.
Let me just close by saying this model is not for everything. I hear a lot about let's use the COTS model. I was reading in the news today, let's use the COTS model. It's not for everything. There's got to be some key ingredients. And one thing is you cannot be assured of the outcome, okay? We took a chance. There is a certain element of a risk here that was calculated, but we cannot be assured of the outcome, and we had to be able to tolerate that. And in the case of the space station, we had some tolerance because there were alternative methods to get cargo to the station with their international partners. But it's not for everything. NASA... when NASA takes on a project, you can be assured it will be done. And given enough time and money, it will be done. So not for everything. Got to have the right ingredients. But when those ingredients are there, I think it proved that it could certainly be a very successful model for developing new systems. And I just certainly want to say thank you to everybody for being here today, and congratulations to both of you for making NASA very proud and the nation very proud to continue our leadership in space exploration.
We've got time for a few questions, a couple from headquarters, and we'll go out on the loop. If you come up to the mic if you've got a question. Anyone at headquarters? Okay, anyone on the loop have a question for the panel?
This is Dana from Maine. I have a question on the track tickets.
Okay.
How is that a software on the internet, or what is that?
It was actually a software program, I think, that was meant to track software changes, and they adapted it to their specific needs.
It's open source.
Yeah.
It's open source available.
We use the same thing for our software development.
Oh, great. Thanks.
Thanks, Dana. Any other questions on the loop?
Yeah, hello.
Go ahead.
Wayne Frazier from NASA Safety Center Alphaport. For Alan, I was intrigued. You said NASA had no statutory authority to provide GFE, but yet if we look at the administration and Congress wants us to do this, was it just a legal interpretation? Was it really that we found we didn't have the authority, and what's the remedy?
Well, it turns out the legal analysis shows the authority does not exist like in a contract we do, but under the Space Act itself, it doesn't give us the legal authority. So we are pursuing changes in legislation to provide that authority when needed, and we're also taking incremental steps. Mark Tim here at headquarters has made great progress in at least in the interim, allowing for a directed sale without going through the entire excess process and GSA and things like that. So it will require a change in legislation, and we have submitted that, and that's being worked, but those things don't happen overnight.
Thank you.
Thanks, Wayne. Any other comments or questions from the field centers?
Yeah, this is Jim Peters at Johnson Space Center. I had just one quick question. Back in 2011, you mentioned the fact that a number of milestones were added. 40, I believe, was the number for risk reduction. And additional funding was granted, $396 million. But my question is how that risk system was managed and who made it to add those milestones, or how were the decisions reached?
Okay.
They identify the risk, go ahead and assign milestone tasks to mitigate those risks.
Okay, well, let me get the numbers right with you. In SpaceX's case, we added 19 milestones for a total of 40, and it was $118 million of value each company. It was important to us to split that evenly because we were fortunate enough to request and get the money we asked for, so we applied it evenly. It was $118 million each, 19, and I think it was another dozen or so for Orbital. And the way we did it was we worked together. We sat down and said, what is the best way to reduce risk and increase the chances of success? And we had working meetings with Orbital and SpaceX, and we decided together that adding these milestones were the best thing we could do. So.
Okay. Thank you.
We've got time for one more question on the loop.
Yeah, I have a question. I wondered how the participants felt that the partnership went with the FAA for public safety.
I guess I'll start. Anytime you're developing a new relationship, there are kind of hills to climb. But in general, and certainly in the final analysis, our relationship with the FAA is extremely positive. We've learned how to work together and resolve issues together. So as a matter of fact, I actually wanted to thank our additional mission partners in COTS. In addition to NASA, of course, we had the FAA, the FCC, as well as the 45th Space Wing.
I agree with Gwen. The relationship with FAA was excellent, and they were involved from the very beginning of the Space Act agreement in a lot of the reviews, the meetings. They stayed up with what was going on. They looked at what they would have to do to do their job in licensing these launches, and we had a good relationship going all the way through, and the licensing process went very smoothly. They participated in the launches. We're still building on exactly how that relationship for range safety needs to progress, but we've made a lot of progress in that area. And like Gwen said, the FCC also got more heavily involved than we had earlier anticipated, but we're moving in the right direction on that too. So it's a multi-agency requirement, or multi-agency activity when you're doing things on a commercial basis.
Okay, that's our hard cutoff. I'd like to thank Alan, Bruce, Mike, Gwen, Frank. Thank you very much.